Thank you, Rich. Again, excited to be here. Thanks for having me. Rich completely took all the content from my first slide, so I won't spend too much time on this. But again, my name is Chris Munns. I'm a principal and lead developer advocate for Serverless at AWS, based out of our New York City office. I've been at Amazon for a little over 7 years, but traditionally came from more of an ops background, or what might be considered today a DevOps background, or an SRE background, or whatever you might want to call that. But I used to take care of servers and server farms and manage Linux and do all that stuff. But for the last 2.5 years, I've been able to focus all my time on this topic of serverless, which I've been really excited about since even before AWS first announced Lambda, which is kind of the core of what we consider serverless today. And I'll talk all about that. So why are we here today? What is kind of the focus of this talk? And I got put in touch with Rich a couple months ago, and we were ruminating on what it is that we should discuss. And one thing that I spend a lot of time talking about is kind of the future of where technology is going. Now this is a fun slide. I've been using this image now since it first came out. What's great is I know that almost everyone in this room knows what this is because of the fact, well, actually, does anyone here in the room not know what this is an image from? A couple people? So a number of months ago, SpaceX launched a rocket. It had 2 boosters on the side of it. And this is actually the picture of the 2 boosters landing, not taking off, but landing on platforms in Florida after they had helped put the main rocket into space. And so they landed almost in sequence. They survived and have been reused, and that's a big thing that SpaceX is pushing. And so it's kind of an incredible breakthrough that they've been able to work on this and get these rockets to land. Anyway, I think it's an exciting view towards space and what's happening in that world. But in order to talk about the future, I need to talk a little bit about the past. And so I'm going to talk a little bit about Amazon internally and how we've built products and how we've changed over the years. Are there any ex-Amazonians in the room by any chance? Cool. Okay, that means no one can call me on my bullshit, so that's good. No, I'm just kidding. Actually, people have come up to me afterwards and been like, wow, I never really contextualized it that way. That's interesting. So if we go back to Amazon, started in 1994, that's when Jeff Bezos first kind of founded the company and kicked the tires on it. If we were to go all the way up through 2001, if you did anything on Amazon.com, so again, before we had AWS, but if you went to Amazon.com, you landed on the home page, you went up to the search box, you searched for whatever you were looking for, which back then was a much more limited product portfolio or number of categories. Went to a search results page, clicked around on different products, eventually added some to your cart, went to the checkout process. All of that was one large monolithic application. In fact, it was built primarily in Perl back then, and it sat in front of very traditional large enterprise relational databases. And we kind of reached an inflection point in 2001, which was basically right in the midst of the dot-com crash, where as a business, we were not able to move as fast as we'd like. And we had a lot of challenges with expanding the product, with expanding the categories, with growing what we were trying to do. And so there's kind of a semi-famous edict that came out from Jeff Bezos, kind of a small little Friday afternoon email that basically said, oh, by the way, when you come into work on Monday, we're going to be a completely different company. We're going to look and feel and operate very differently. And it basically went on to shape how we operate and how we organize ourselves and how we build software from then on. So basically from that point in 2001, 2002 onward, we became an organization focused on today what we would call microservices, organized in a structure that we call 2 pizza teams. Now, I often like to joke that after a number of rounds on a Friday night, you might challenge yourself to be a 2 pizza person. I don't recommend that, but essentially what it means is about 6 to 10 people that work together as a unit focused on either an entire product or some part of a larger product. And this 2 pizza team structure basically owns everything about it. So they own the product planning, the development, the operational support, the roadmap, all of the things about the component that they basically build. Now, in order to enable this to happen, what we do in Amazon is we give our developers what I like to say is kind of a fairly fixed box of tools. And so if you walked into a Home Depot or a Lowe's somewhere here in Silicon Valley and you went up and you bought the Craftsman starter toolkit and say it's got 50 pieces in it. If you bought that here in the Valley, or you bought it in New York City, or you bought it in Texas, or you bought it in Seattle, that 50-piece toolbox is pretty solid. It's going to be pretty much the same in any of those locations. And so I have another slide here which goes towards my ability to make slides, which is one of the world's worst Venn diagrams, and that there's basically no overlap between these two circles. And so generally speaking, what we do is we try to provide this toolbox, basically the stuff in the blue, to our developers so that they don't have to think about those things. So we don't want the average developer at Amazon thinking about deployment tools, management tools, monitoring, security, infrastructure management, any of that. We want them focused purely on their product. Now, much like at that Home Depot, if you bought that 50-piece starter toolkit and you went up to the Home Depot rep and you said, I really don't want the wrench that's in here, I want this other wrench on the shelf, they're not going to say, oh yeah, just swap those out. They're going to say, okay, well, you have to buy that one too, and then you own that one and you own the one that's in that toolkit. Similarly, if teams at Amazon say, you know what, I need a different logging tool, I need a different deployment tool, I need something else, then it becomes something that they own. So it falls into that green circle. And now when you only have 6 to 10 people essentially working in some sort of bounded context, the more stuff that you throw into this green circle, the less time you have to focus on your core mission, which is your product. And so it's a really kind of easy carrot on a stick that guides people towards focusing on their product, using the kind of, again, fixed box of tools that we have without them having to, again, own the responsibilities for operating, managing, and owning those components. Now that said, this green circle still has a whole lot of stuff going on in it. So it's all of the other things that you'd all be familiar with here. So they have to actually write the code. They have to maintain that code. They have to potentially take care of the infrastructure that they're managing, that code runs on. And now we very early on in the 2000s built out essentially our internal infrastructure as a service that predated AWS, that had kind of internal platform as a service offerings, again, that predated AWS. And by and large, Amazon has used those technologies internally for over about a decade before moving towards the ones that we now have on the AWS platform. So there's a lot of things that developers still have to think about. Operational runbooks, testing, compliance, security, all of these various things that, again, that 6 to 10 person team, while there's still a lot of institutional knowledge sharing, still has to think about that stuff. Now we understand that all of these things that are not their product development take time, and so basically what we do is we try to find a balance point between the product development and then what we consider kind of the operational tasks that those teams have to own. And just to be clear, so these two pizza teams, they support on-call, they're responsible for their infrastructure, there's no dedicated NOC at Amazon, there's no tier 1, 2, 3 infrastructure support really. You own your resources on top of that infrastructure as a service provider. And so finding the balance between the development tasks and the operational tasks are really key. And so one thing that we're constantly doing is looking at this green circle and saying, what can we shift over to the blue circle? And so, again, very early on in this kind of shift from this monolith to this microservices to pizza team model, we started looking at all the places where we could invest things into the blue. And again, that led to kind of the early genealogy behind the concepts of AWS, which is now this cloud provider that has 160 or so products today, is thinking, again, how do we shift from the green to the blue? So that's us. In the meantime, there's a number of other trends and things that have been going on in the industry. And so Mark Andreessen, famous Silicon Valley VC here, has said that software is eating the world. This is a phrase that he's become quoted on pretty heavily. In response to that, a gentleman named Dr. Scott Wilmot, who was at Red Hat for a long time, I think still there, kind of retorted with that APIs are eating software. And so there's kind of a very well-known book on this space by one of the authorities in it called named Sam Newman from ThoughtWorks. He wrote this book called Building Microservices. And so my quick biology lesson for everyone here in the room is, does anyone know the relation between honeybees and the Building Microservices book? Anyone? No? So if you happen to open up your favorite web browser and go to your favorite search engine and search for APIs, you might think that that's APIs. It also happens to be Apis, which is the genus for honeybees. And so you could end up finding a lot less about things like REST and GraphQL and building web APIs, and might get a small little lesson in honeybees. And so I don't have official confirmation from the folks at O'Reilly or from Sam himself that that's what this alludes to, but I'm pretty sure that's what this alludes to on the cover of his book. Really incredible book, would encourage everyone in here who's a software developer, infrastructure person to pick it up. Just really, really strongly well-written book. Now, similarly, when we talk about APIs, we talk about how APIs are kind of powering the new world around us. And many of you are probably writing API-based software. You create and build devices that are powered by APIs. Most of us are carrying or wearing or drive or sleep next to or pretty much surrounded 24/7 by some sort of a device that is talking over some sort of a web API. And so it's true, what Mark Andreessen said is that APIs are what Scott Wiltemont said is that APIs are basically eating the software world. So at the top, just some examples of physical devices that are based on APIs. At the end, we have the Illumina DNA sequencer, an incredibly important device that helped enable a quick and easy DNA sequencing of things like cancer cells and stuff like that, where if we go back about 15, 16 years ago, the first human DNA sequence that we did of the genome cost billions of dollars. Today, if you're unfortunately ill, you can get your doctor to do a biopsy DNA scan on cancer cells for about $1,000. So pretty groundbreaking stuff. Again, all talk APIs. And then if we look at the bottom organizations here, these are companies that are either heavily built internally on APIs or provide APIs outbound. So if we think, for example, of Square or even Slack to a degree, all powered by APIs. So APIs shifting things. You might even find that there are APIs in your microwave these days. So this is an Amazon Basics microwave, and if you're paying enough attention to the buttons over here, you'll see that my good little friend Alexa is actually embedded in this microwave. And so you can say things like, Alexa, cook my popcorn, and it saves you from pressing about 3 buttons. So clearly changing humanity. But at the end of the day, what we find is that voice is becoming more and more impactful and showing up in more places. Real quick on voice, they basically talk about the growth of voice is going to surpass the basically interfacing that we do with technology around us from a traditional UI perspective, probably by 2030. We'll be doing way more with voice than we're doing with our fingers. And so basically what we see is kind of voice as the next primary interface for interfacing directly towards technology. Again, there's a number of different stats that just show voice search is kind of up and to the right. Again, going to surpass keyword searches very, very quickly here. So again, here at Amazon, we have our good friend Alexa. Alexa shows up in many different places. How many of you have some sort of smart voice-enabled device at home? Either Alexa, Google, Siri, yeah. And again, if you've got one of those devices in your hand or in your pocket or on your wrist, you're probably dealing with this. But so voice, really, 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 really important. But at the end of the day, all of this voice stuff driven by APIs, typically driven by microservices. And so this architectural paradigm of how we're building this software is really fairly similar. If you're building software for one of the major voice-enabled services, you're building it pretty much all the same across them. There's not a lot of uniqueness to those. So we say that APIs are the front door of microservices, and again, internally at Amazon, we've been building microservices since the very early 2000s. This is kind of a semi-famous image that we have from about 2008 to 2009. It represents all of the microservices that existed inside of Amazon at that point. This is across all of Amazon. And so the black lines represent basically the dependency trees effectively between all of these. And so at the center of this is, yes, the thing that the Millennium Falcon could fly into to blow up this Death Star. And in that case, it's things like authentication, identity, user management services that are basically key to a platform like Amazon's. If we have a problem with our auth products, we have a very bad day. A little bit more kind of in talking about this, when we talk about services at AWS, S3 was technically the first generally available service that AWS had back all the way in 2006. And so when S3 first launched, it was effectively 8 separate microservices that made up that consumed product. And so there's various levels of back-end services that control what you did when you interfaced with that product. How many of you here know what S3 is? A bunch of people? So for those who don't, S3 is a storage service. Again, it was the first product that we launched at AWS, and basically what you do is you can store files up into it. There's a really good chance that if you use a major photo app or a major file sharing app, at some point or today, it is still either built on S3 or built on something similar to S3 or has used S3. So one of the core technologies that powers modern applications today. Now, so this was us in 2006. If we jump forward to 2018, and these are screenshots from a keynote at our user conference called reInvent, which just happened back last December, S3 is now more than 235 different microservices. So in about 12 years, we went from 8 to 235. So again, kind of this expansion of this. Now we see microservices all over the place. Again, I'm based in New York, and there's a story that I like to relate back to, which is a company called Gilt. I don't know how many of you are familiar with Gilt. I see more women in the room shaking their heads. It was a retailer that sold a lot of clothing, had a little bit more of a female bias in the customer base, I would say, or demographic. But they have a story similar to Amazon's, different scale, moving from the monolith to kind of an SOA-based model to then to microservices. And so in 2011, there were about 2 to 3 dozen kind of SOA-ish services. When they jumped forward to 2015, they were all of a sudden 300 or so microservices. And what they did to enable this was very similar to Amazon. They had a fixed box of tools. So they gave their developers a fixed box of tools, said build stuff with this fixed box of tools, and by and large, people did that. We see similar models at companies like Spotify and Airbnb and Netflix. Again, this concept of a fixed box of tools. But they also had some really interesting stats that they drilled up. And again, this was back in, I think, technically 2016 that these stats came about. But basically, if we looked at the services that they had, they typically ran on just 3 hosts. So one per what's called an availability zone in AWS. And so at AWS, we have this concept of regions, which is basically geographic areas where we have lots of data centers. Those data centers will be either individually representing what's called an availability zone, or they'll be grouped together in it. It basically allows you to construct for high availability and fault tolerance. So in this case, they would have 3 instances for fault tolerance, not necessarily for scale. Those instances were typically 1 virtual CPU and 1 gig of RAM. Now, for most of you that have a modern mobile phone in your pocket, your mobile phone is probably somewhere 4 to 6 to 8 times more powerful than this. So 3 hosts, really, really small amount of CPU and memory, again, largely just for availability context. And then they looked at the amount of lines of code that they had per service, and roughly what it worked out to be was about 2048 lines of code per microservice. So again, 300 microservices, roughly running on 3 instances apiece, really small instances, about 2,000 lines of code per. So we'll come back to the importance on this in a little bit. Now, internally at Amazon, like pretty much every other organization at the time back when we first launched, we ran on physical hardware. And so we had lots of physical hardware, and we spent a lot of time and a lot of investment in scaling that physical hardware. We've been supporting Cyber Monday and Black Friday for a really long time. Historically at Amazon, those have been the biggest days of the year for us. We now have something called Prime Day, which we started doing about a decade or so ago, I guess now, and that now is also considered one of the largest e-commerce shopping holidays, largely also because many of our competitors participate in the Prime Day time with deals and offers and stuff like that. But if we look at the evolution internally at Amazon, we had physical machines, and then pretty early in the 2000s, we moved on to virtualization. So we had a kind of an initial version of our virtualized infrastructure, which today looks a lot like EC2 did when it first launched. And then what we've seen also is then an evolution from virtual machines into containerization. Now, a lot of people think about containerization in terms of things like Docker and Kubernetes. But if we actually go back to 2009, 2010 and look at products like Heroku, Heroku was largely built upon the ability to do basically virtualization in the Linux kernel inside of a virtualized environment. And so at Amazon, we actually have not done a lot with containerization back in that time period, although today now we have many products in this space. So general progression in this way from having the physical machines, then to them being virtualized, then to containerization. And again, basically what you're getting as you evolve on is smaller bits of compute resources, higher levels of abstraction, really kind of greater flexibility in how you use that. Okay, so let's step back again here a little bit further in talking about Amazon. So I mentioned again at first, there was Amazon S3. Now again, we say this is the first service for AWS. Little caveat, the first service was actually called Amazon SQS, which is our queue service. So not the most exciting service, but it actually predated S3 by I think about 2 years. But anyway, S3 was the first service. And so when we first launched S3, the way that it works is you have something called a bucket. The bucket essentially represents a namespace in our storage infrastructure, and you put objects into it. And these could be images, videos, text files, backup files, binary blobs, objects of whatever you might want to have it be considered. And so from when we first launched this project in 2006 up to 2014, you would put these objects into this bucket, and then you wanted to do something with those objects. And what would you do? How would you access them? Again, you want to process those images, those data files, those backups, those videos, those log files, whatever it might be. And so a common way to solve this problem was to build several pieces of infrastructure around it, which would basically look for changes in that bucket or to the objects in that bucket, pull out those changes, pull out those objects, and do that processing. And so there was a fair amount of complexity in doing all of this. Often you had customers that would do things where they would basically create a parallel request to our queue service or to some sort of messaging bus, and then also pass that on into compute infrastructure so that it would say, okay, now let me download that object and do this compute action on it and all of that. And so this complexity was kind of unnecessary, right? You just want to get some data, you want to process it. Why do you have to run all these other subsystems to make that happen? And so there was a big drive for us to make this specific thing easier. Similarly, a couple years later in 2013, we announced a product called Amazon Kinesis. And Kinesis we now call Kinesis Data Streams, and what it allows you to do is to ingest data points. It was initially really popular with companies that did things like click tracking or ad tracking, or also companies in the IoT space where they were collecting sensor data. And you could think of Kinesis as enabling massive ingest of information, and then very similarly to S3, you get that information in, and you want to do something with it. So what do you have to do with it? And so back when we first launched this, what you would have to do is run a fleet of compute resources. They would actually basically have to pull onto this stream. They'd have to pull down the information. And because we take care of things like ordering and to a degree kind of the data stream integrity, you'd also have to checkpoint that data up to some sort of a database, in this case DynamoDB. So again, just to read data out of it, you had to run a couple of different components. And so this too was quite a bit of complexity. So our CTO, Werner Vogels, has a phrase that he's been using for a long time now, which is that no server is easier to manage than no server. Funny side story, I wanted to use this screenshot image of Werner in a presentation a couple years ago, and when I had to go through PR review, they're like, oh, you're gonna have to check with Werner if you can use that image of him. And I was like, okay, how do you guys do that? And they're like, no, we don't do that. You have to email Werner and ask him if you can use his likeliness in a presentation. And so I was a fairly lowly solution architect, and I had to email the CTO of Amazon, and I'm like shaking my fingers as I type in this email, and I'm like, dear Werner, I'd like to use this image, explain all the context, and then like 45 minutes later, I just got back like okay, looks good. And it was like all this pressure built up to use this image. But now I know that I have Werner sign off to use this image in his likeliness. So again, this concept of how do we get customers away from having to think about running these servers? That's my ominous music. No, that's not my ominous music. I don't know what that was. And so in 2014, we announced a product called AWS Lambda. And so Lambda basically is a compute service. And the idea here that we want to do, if you look at the section that's highlighted in the blue, is that we want to handle all of the administration of the underlying compute resources, including server and operating systems management, capacity provisioning, automatic scaling, security deployment, code monitoring, logging, et cetera. Basically, you just write some code and it takes care of all the rest of this for you. Note in this initial announcement, there was no use of this term serverless. And actually, it was a full year later before basically we started using the term serverless with Lambda, actually in response to other people doing it. But so basically what this did was you took that S3 bucket, you pointed at a Lambda function, and what would happen is S3 tells Lambda, hey, there's a new object in a bucket, or there's been an action on it, and behind the scenes, it automatically sends the information to Lambda, and it can process whatever happened to that object. Similarly with Kinesis data streams, basically the same thing. You just point Lambda at that data stream, it automatically scales it up behind the scenes, it takes care of the checkpointing and the data integrity and all that stuff for you. So completely simplified these two workloads. And it was actually the first one here, S3, that actually led to the initial basically funding and ideas behind Lambda. So Lambda was initially a storage service. It wasn't a compute service at AWS. Then in the summer of 2015, so a full basically 9 or so months after we announced Lambda in 2014, we announced a product called Amazon API Gateway. And this allows you basically to have clients that talk to an API gateway, and then that API gateway maps back to Lambda for REST APIs, and now today REST and WebSockets. And so when you look at these three workloads of basically file object processing or batch processing, streaming data processing, and then RESTful web API processing, they represent a bulk of the biggest workloads that we see out there for how you think about product design. Also in that same year, in 2015, we basically announced that we were opening the ability for developers to create custom Alexa skills. And so, again, this is on Werner's blog here, where he talked about enabling you as a developer to just write your skills into Alexa. This was pretty groundbreaking at the time. Siri had been around for a couple of years at this point. There still today really isn't much of an API for writing custom Siri capabilities. Google's voice product wasn't really quite in existence yet. And so Alexa was really the first voice service to have this API capability. And in this launch post that Werner wrote, we actually laid it out pretty clearly here, that if you look at the very top line here, it says the easiest way to build a skill for Alexa is to use AWS Lambda. So there was kind of this immediate synergy between the two of those. And so going back to this evolution paradigm, what we see here is that really serverless becomes the kind of furthest evolution of where we've gotten to in compute. You're breaking things down very granular. You've got a very, very kind of small alignment between ideally a single business need and a single piece of code. And so again, the granularity goes from the physical box to the virtual box to the container to the Lambda function. And so behind the scenes, there is a kind of container technology that powers Lambda. Now, when we talk about a Lambda-based application, there's a couple of aspects to it. So there's this concept of an event source. This would be that S3 bucket, that Kinesis stream, that API gateway. You configure that back to a certain Lambda function, effectively addressing it by a namespace. That Lambda function could be written in one of many different languages. So today we have 6 primary languages that we manage for you. So Node.js, Python, C#, Go, Ruby, and Java. We also have something called the Runtime API, which allows you to bring any language that you want to Lambda. We have customers that are running Erlang, that are running C, C++, that are running Swift, that are running PHP. If you want to use a language like PHP, that's totally up to you. And then your Lambda function does whatever it needs to do. So talking to data stores, databases, other APIs on the internet, running compute-intensive various libraries for data analytics and whatever it might be that you need to do. But basically, from the function on, you own all the capabilities of that. Now, it's still running, yes, on a server somewhere. It's actually running somewhere on a Linux server. You have access to the underlying Linux kind of file system and controls and things like that as well. So you're not really having that different of an experience as a developer when writing for a serverless application. So we can basically apply this for all sorts of use cases, right? So then we look at kind of the biggest buckets of serverless applications. We have, again, things like web applications, so being able to power a either static or more dynamic website. We see this becoming a really big trend here I'll talk about in a moment. Powering backends, so internal microservices for things, device backends, IoT backends that all call Lambda directly. Data processing, which actually basically kind of dollar for dollar is the biggest use case of Lambda today. We have customers that are processing many thousands of data records or items at any point in time in like a single concurrency window. And so whether this be market data, clickstream data, sensor data, log data, there's all sorts of different ways that you can real-time stream into Lambda and have it processed. Chatbots and Alexa, which are pretty tightly aligned, but we see chatbots showing up all over the place, external to organizations, internal to organizations, both voice and non-voice chatbots. And then again, obviously things like Alexa. And then lastly, IT automation, which I consider to kind of be kind of the lowest bar for things like serverless, where you've got things that plug into development tools, management tools, security tools. Capital One built a cloud governance tool that uses Lambda to power some of its logic. We've got a lot of stuff like that can happen. So kind of 6 big buckets of use cases for what you can do with Lambda and some of the surrounding ecosystem. One of the biggest ones that I see, which in conversations that I was having with some of the team earlier, maybe not as applicable for as many of the folks that are here in this site for Samsung, but when I look at the broader context of kind of the IT ecosystem, is the amount of just really basic web apps that exist out there. If any of you have built a traditional kind of N-tier Java stack in an enterprise over the last 20 years, where you have a web server, an application server, and a database, there are millions of these stamped out across the Fortune 1000 enterprises that exist today. And so you can move to something like a website built in, say, React or Vue or Angular, so one of the more modern JavaScript web front ends, and then move your backend to something like API and Lambda and some sort of data store. And what you basically get is point-in-time scale. You're not paying for it when you're not using it. So if you have a business that's largely, say, 9 to 5 in a certain geography, well, that 5 to 9 time window on the clock, it's costing your business next to nothing to operate it. And so when we think about, again, all of those application stacks that are out there that power HR apps, sales apps, ticketing site, like internal ticketing wikis, things like that, all of them are eligible for becoming a serverless app someday, and it's going to completely kind of shift the way that businesses think about building these types of applications. So I think this is the biggest trend in traditional IT that we'll see over the next decade. So how does this all help with development? So at Amazon, across all of Amazon, if we look over the last couple of years, we've done a bunch of things with real-time video, essentially machine learning and AI technologies. So all the way at the top here, we have a thing called the Deep Lens, which is a device that you can actually go and buy, and it has a number of capabilities for being able to stream video and run Lambda functions on your behalf against that streamed video. We have the Echo Look, which I'm definitely not bold enough to buy, where you can actually ask Alexa to rate your outfit, and I just don't need that kind of stress and shaming first thing in the morning. So it's not something that I'll invest in myself. We have the Amazon Key, which basically is something that allows you to put this camera inside of your front door, and now we also support it inside of your garage. And basically, when packages are delivered, you can open the door, open the garage for Amazon, and allow them to put the package in for you. You can watch them come in and deliver it, and it will stream the video to you live for the duration of when they're there. Some people thought that we were absolutely crazy when we released this, but the reality of it is that package theft impacts a lot of people around the world. It's a huge problem for the shippers, it's a huge problem for retail sellers, and so this helps solve that problem with, again, the comfort and control of this connected device. We have this vision here of the landing zone from an Amazon delivery drone. So basically what you have, one of the things that they've shown research on is you print out this big A, you put it in your backyard or your front yard or wherever, and the drone looks for it and uses it as a place to drop off your package. And so it's doing that in near real time as the drone is flying. And the last one here, and I know they have a store somewhere in this area, is Amazon Go. And so with Go, I don't have my phone on me, but you open up the app and it has a little QR code on it, and you walk into the store and you scan the QR code, and then you can just walk around the store and take whatever you want. You literally pick it up off the shelf, put it in a bag, put it back up on a shelf, walk around the store, do that some more, and then you leave. You don't go to a checkout line, you don't have to swipe your items, no one has to see it. And basically what's mounted throughout the ceiling of the store are cameras that track your every motion, that track your every move, that look at what you're grabbing, that look at what you're taking off of shelves, and then you walk out and basically you get a receipt. It automatically charges your Amazon account. And so it's funny, when it was first launched, people were like, I'm gonna steal all this shit from the Amazon Go store. And actually it's pretty hard. It's pretty smart technology, it captures most of the stuff. And so we've now expanded Amazon Go into a number of locations, at least around the US. And there's one in New York City and a couple other places. So what all of these things have in common is that they're taking video in near real time and applying AI and machine learning to it. And they're doing it in a way that's pretty data intensive for, again, various different use cases. And so if I look at these and I put on my solution architecture hat and I say, okay, what do I need if I was going to build this? Well, I need to capture video in a near real-time stream. I need to process it. I need to do this AI ML on it. I need to store the data about it. Probably need to apply some business rules and various business workflow on top of it. What would I need to build it? The reality today from AWS is it's about 10 or 11 services that I could uniquely identify across all of these products that could remain consistent. And now what's really interesting about this is that there's only one of these that you would write your own code for, which is Lambda. All of the rest of these are managed services. They're basically those tools in the toolbox that the Amazon developers on all of these teams had available to them. And so when they were thinking about this problem, and these are all different businesses in Amazon. I've been learning a lot more about Samsung today. I understand you've got a couple different offices in the area, and you've obviously got different businesses around the world, and you're pretty firewalled off from each other. You're focusing on different things. These are all very unique businesses inside of Amazon. They are not collaborating directly with each other. But what's common across them is that they're probably utilizing these types of services behind the scenes for these very, very different use cases. And so again, in this case, they're only writing business logic with Lambda. And so what that means is, again, we're really, really simplifying the amount of work that the developers have to do. Now, going back to this story from Gilt, where again, it's basically one host per availability zone, one vCPU, 1 GB of RAM, 2,000 lines of code. This is basically what a Lambda function is meant to be. Lambda functions give you anywhere from 128 megs of RAM up to 3 gigs. You typically have 1 to 2 CPU cores, and lines of code for Lambda functions typically are in the sub-hundreds to low hundreds. And so this basically looks just like a Lambda function. So essentially Gilt built an infrastructure that could align back to being about 300 or so maybe different Lambda functions. So actually over time, back in 2018, Gilt said that actually they're moving towards serverless because they realized in their head that box of tools they'd given their developers still had a lot of burden in it. And so they could actually move towards something like Lambda, unify even further that box of tools, accelerate development, and so forth. And so when we break this down a little further, from a scale perspective, if you look at a typical monolith in an organization, for most kind of organizations that have been doing development for over a decade, your monolith is probably in the many millions of lines of code. Maybe you've been doing microservices or service-oriented architecture, you're in the thousands of lines of code. But with Lambda, being in the tens to hundreds of lines of code has a massive impact. And so basically what you end up with is much more simplified testing of the code, right? If you're writing test cases for a couple hundred lines of code, that's very different than writing test cases for millions or hundreds of thousands of lines of code. Much easier to onboard new developers. Hey, here's our constrained code base. Go read about it, go dig into it, go learn and understand it. Faster deployment times. You could do orchestration in these managed services. Again, those other 12 services besides Lambda, the developers aren't interfacing with the code for. They're just talking to their APIs. Basically gives you a reduced blast radius of issues because you're only focusing on so much of the overall product. And so basically then leads to, ideally, greatly reduced technical debt. So all of this comes from just writing less code. So going back to the Amazon story, when we look at this and we say, well, what happens if we can reduce operability? Because we're just getting rid of all this operations work that we used to have to do. And then we also reduce the amount of code that we have to write. And basically what we get to look at is 2 pizza teams, 1 pizza too many? Instead of 6 to 10 people, can we basically do the same amount of work with 4 to 5? And actually a number of the companies that I've talked with find that this smaller kind of pod size could be really, really, really effective. And so I had a slide that I just realized that I stripped out of this deck, but in 2016, we have a number for the number of deploys that happened in Amazon. And in 2016, I believe it was over 60 million deploys that we did in that year. Works out to be more than a deploy per second of every second of the seconds in the year. But if we took this model and we said that 2 pizza team sizes are too big and we can move to 1 pizza team size, then how much velocity could you have as a business? And again, because you're focusing on that green side of that Venn diagram from before, not the blue side. And so what that lends us with is basically, as a business, we could do a lot more with less. So we can invest in new products and in new areas with a much smaller headcount, a much smaller initial investment. We don't have to spend a whole lot of time with hiring. If we're using more of these managed services, it means less drift. So there's a lot more standardization inside of the business, which helps with portability of people and teams, moving from business section to business section, and so forth. Again, straightforward things like greater agility and time to market. You're not dealing with availability concerns, and so on and so forth. And so, again, going back to those five different products that I mentioned that were sold from completely different parts of Amazon, they're being able to make use of some of these benefits because of this. So just kind of wrapping up here, when I talk about the future of where all this is going, now I'm giving the context for what we see inside of Amazon and how we think about this space and how AWS has impacted back to the rest of the Amazon business. But I think what I see from some of the biggest customers that we have around the globe is, again, that thought of what are the things that we're spending time in the green circle on that we can shift over to that blue circle. So what are the things that we're technically treating as your product that could be moved back up to a platform or a managed resource or something similar? And I think by and large, we're seeing many, many organizations look at doubling down that investment in the green circle to the blue circle. I happen to be pretty biased in thinking that serverless as a compute construct helps enable it even easier. But essentially, that's kind of where I see the future of this space going, and I think we see some pretty good market trends that support that. You can read a lot more about the technology side at aws.amazon.com/serverless. Again, my name is, let's take a photo of that. The video is going to be posted on this, and I think the slides will be shared as well. But my name is Chris Munns. You can find me at munns@amazon.com or at Chris Munns on Twitter. I've got a couple of minutes here to take some questions from the audience, and so I only ask that you come up to one of the mics that's available here, and I will try and address any questions that I can for you. But thank you for coming today. Hopefully you've got a little more insight into what the space of serverless is, where it came from, and where it's going. So thank you.